Chapter 15, Section 4, Exercises 3a and 3b. We will evaluate the given line integral, first directly, and secondly, in Exercise 3b, by using Green's theorem. In Exercise 3a, I'm simply going to read through the handout that I've already written up. To evaluate this line integral directly, we notice that the boundary, which is C, the closed curve, is made up of three different individual curves. You can see how I've labeled them. Here's C1, here's C2, here's C3. On C1, x equals 9. In fact, C1, the line segment, is a portion of the vertical line x equals 9. Since x does not change, dx is equal to 0. So dx is 0 and x is 9. And you can see this in the second integral. Simplifying, we get the integral of 9y with respect to y from 0 to 3. Here the y coordinate is 0, and here the y coordinate is 3. That's a simple calculus calculation. We evaluate 9y squared divided by 2 from 0 to 3. We get 81 divided by 2. Now, let's look at C2. We'd have to parameterize it. If C2 were oriented in this direction, the parameterization would be x equals t, and since y equals square root of x, y equals square root of t, from 0 to 9. However, the orientation is in this direction. So we will use the following parameterization. We will let x equal 9 minus t, and again, since y equals square root of x, y is square root of 9 minus t, 0 less than or equal to t less than or equal to 9. And let's double check that we have preserved the given orientation. When t is 0, we are at the point 9, square root of 9, in other words 9, 3. And when t is 9, we are at the point 0, 0. So we are going to put x, which is 9 minus t, right here, and we are going to put y, which is square root of 9 minus t, right here and right here. Well, what is dx? Well, since x equals 9 minus t, dx dt, the derivative of x with respect to t would be negative 1, and that means dx equals negative 1 dt. You can see that right here. Similarly, since y equals square root of 9 minus t, in other words, 9 minus t all to the 1/2 power, dy equals the derivative dt. And the derivative is 1/2, 9 minus t to the negative 1/2 times negative 1. Therefore, we have y squared, which turns out to be 9 minus t, dx, which we computed, plus x times y. X is 9 minus t all to the first power, y is 9 minus t all to the 1/2 power. We add the exponents 1 and 1/2, and we get 3/2, and then dy as we just explained. From here it's an easy algebraic simplification. We get this integral in t and this end result. Now let's look at C3, the last curve. We'll notice that C3 is a line segment that is part of the horizontal line y equals 0. Well, if this term has a 0 factor and this term has a 0 factor, then the entire integrand is 0, and that makes the integral total value 0. We add up our three results, the 81 halves, negative 243 fourths, and 0, and we get negative 81 fourths. Let's see if we get the same result using Green's theorem in Exercise 3b. Again, we will call this capital M. Here we have n. Since m equals y squared, the partial of m with respect to y is 2y. Since n equals xy, then the partial of n with respect to x is equal to y. So by Green's theorem, this line integral is equal to the double integral over the region R, highlighted in yellow, of the partial of n with respect to x minus the partial of m with respect to y. So we have the double integral of negative y dA over the region R. We will integrate using vertical strips. That means our inside integral will be with respect to y. Now each vertical strip goes from this line, which is y equals 0, up to this curve, which is y equals square root of x. And there is such a vertical strip for each x value from 0 to 9. So our outside integral is with respect to x and is from 0 to 9. Again, this unpacks pretty easily. We have negative y squared divided by 2, evaluated from y equals 0 to y equals square root of x. Put square root of x in here and I get negative x divided by 2. I put in 0, I get 0. Integrating negative x divided by 2 with respect to x, we get negative x squared divided by 4, evaluated from 0 to 9. You put in 9, we get negative 81 fourths. Put in 0, and we get 0, so our answer is negative 81 fourths.